Right, so today we're going to be talking about some of the information that we need to know into graphing polynomial functions. So as you see, this is part one. There's going to be multiple parts throughout this because there's a lot of stuff involved. We need to know, well, what is a polynomial function? How do we know if it's an actual polynomial function? The parts of the function itself, how to evaluate it. That's all part one. Then part two, we'll get into the parts of the graph. And then part three will be actually graphing it. So it's a lot of information. That's why I broke it down into these few parts. So the first part is we're going to take a look at, well, what is an actual polynomial? So first off, we need to know is what is a monomial? Mono means one, singular. So monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. So that's really important there. They have to have whole number exponents. In the red arrow, there's no plus or minuses between any terms. That's how we know that it creates one single term or a monomial. So -7, 2/3, 0.5. So any number we could possibly think of, rational or irrational. X squared, 2/3 x squared. So I could put things together. That's fine, as long as it's a product, a multiple. XY cubed, two things multiplied. That's fine. -y divided by 7. And I know that technically doesn't look like a product to you, but remember, I could rewrite this as -1/7 times y. So division is actually considered a product because we can write it as multiplication of the reciprocals. So these are all examples of a monomial. Now, if we put those together, if I was to start putting in plus and minus signs in between all of these terms, that's what creates your polynomial. Poly meaning many. So it's taking each monomial, adding or subtracting whatever I have together. And again, the same rules I have to apply. I still need to have whole number exponents for it to be a polynomial. So I just took some of the random monomials I gave you up there and I added them together. 2x squared plus xy cubed minus y/7. Right? That is considered a polynomial. So a polynomial function is in the form f of x, function notation. You could also see y equals a sub n x to the nth plus a sub n minus 1 x to the x minus 1. Actually, that should be n minus 1. Excuse me. So basically, it's decreasing. Let me fix that. That should be n minus 1. So again, it's just going in decreasing order. So it's standard form as long as I have my largest exponent first, and I decrease as I'm moving my way down. So it could be anything. I could have x to the 10th power, and then it would have to decrease in order. And it always goes down to the constant. Now we're labeling the constant as a sub 0 for right now. Now, other parts we need to be aware of is that a sub n we call our leading coefficient. It leads the entire polynomial, so hence leading coefficient. And then whatever exponent is attached to that leading coefficient, we call that the degree. So in this case, the degree would be n, or whatever I would have here. And its leading coefficient is a sub n. And again, it goes in descending order all the way from the largest down to its constant at the end. Okay. So we're going to go through and take a look at whether or not some things are polynomials and how to decipher their leading coefficient and their degree and their type. So before we can do that, we do have to talk about, well, what are types of polynomials? So a type is a constant. So if we just have a single number, f of x equals -14, that is a constant. There's no other values. So that's its type, constant. And its graph would just be a single horizontal line. We have linear functions. We know linear functions, y equals mx plus b. So in standard form polynomial world, it looks like a sub 1 x plus a sub 0. Or like we had this example, 5x minus 7. Those are linear functions, lines on the diagonal. Whether it's positive or negative, just depends on the leading coefficient. Then we have our quadratics. Those are our U shapes. Their biggest degree is a 2. We have a cubic, which its degree is a 3 in its graphs, and then a quartic in its graphs. Okay, and again, knowing their degrees. A constant, which I did not mention before, it's a degree of 0 because there is no variable. So the variable would technically be x to the 0, which doesn't exist. It's basically 1. Okay. So it's a degree of 0 there. All right, so as we go through, like I said, we're going to look at given polynomials. We want to be able to write it in standard form and state its degree, its type, and its leading coefficient. So real quick, I'm just going to go through number 6 right here. First thing you do is you look at your variables. So I have an x and x squared. I have whole number exponents, so that's great. So I know this is a polynomial. Okay, so I could say, yes, it's a polynomial. And then we want to put it in standard form and write the degree, the type, and all that. So standard form just means I need my biggest exponent first. So that x squared is going to come first with its term. The negative 12x will be my second term. And that the square root of 3 is the constant. There's no variable with it. So this is my standard form. And then from there, I could say the degree. Well, the degree is 2. That's my highest exponent. The leading coefficient, I'll shorthand it as LC, is 13. That was the number that leads my whole thing. And the type would be a quadratic because it is a square. Again, if it's a single, that's your linear. Squareds are quadratics. 3s would be cubics. 4s would be quartics, and so forth and so on. Okay. All right, I'm going to erase this before we move on to the next slide. Okay, and then right over there, it just says that you have to take note of your variable's exponents. If it's not a whole number, then it's not a polynomial. So again, if I look at something and I notice it does not have a whole number exponent, which we will see some as we go through practice problems, then it's not a polynomial, and we would not be able to write it in standard form or the degree, type, or any of that stuff. Okay. Now, the last thing in this section is evaluating. All that means is you're simply going to substitute in the given variable and solve. So they're going to give you an x, you're going to plug it in, and you're going to put it in your calculator, and you're going to get the evaluation of the function at that point. Just make sure that when you write it down, that you write it in your function notation. So you're substituting -2 in for your x. Okay, and then you would proceed and put that in your calculator and come up with a value. Okay, I'm not going to go through that all right now, but that is basically what you're doing and finding out what it equals. Okay, so that is all part 1